Hi, this is Mr. Yeager. What we're looking at today is basically how to use a direct measurement video. These are activities, a particular website that we're going to be using quite a bit throughout the year. And one thing that has come up is, I've seen people kind of struggle how to use these if they're not shown a little bit more in detail. A lot of times it's people overcomplicate them or try to see things that aren't there. And I try to sit there and go, this is what we're looking at, this is what you need to do. And then it doesn't matter what topic they go through, they can go ahead and use these. So these are not mine. I did not create these. These are from a website called Direct Measurement Videos. It's funded by National Science Foundation, created by quite a few different people from different universities across the U.S. And I mean, you can find it at this website, sdrc.carleton.edu. Again, excellent videos. Not mine. This belongs to them. But obviously has been available to all of us to obviously use to try to understand physics better. So I just want to try to show a couple things. This is the two videos I'm about to show are videos you will analyze. I'm going to go through the process of how you might analyze it. I'm not going to do the exact problem, but it might be very similar to what you have to solve. So again, we want to try to see what's going on here. So if I take an initial look at this video, basically what I would do with the video is I'd let it run to kind of just see what's going on. They're not long, okay? So basically it's, you have these ice skaters zooming on across the ice, all right? You can see obviously a couple things that we can focus on. We have frames being counted, all right? And then we have these two lines with a space in between saying the distance between those two lines, those 2 points, is 5 plus or minus 0.1 meters, okay? And so that is really all the information given to us, but we can do a little bit with it to solve some kind of maybe kinematic problems, trying to relate maybe the speeds and velocities of the different people, okay? And so it stops. So again, down at the bottom, we have a couple different tools. We have one that just resets it, the double arrow. We have the play pause button, so obviously you can stop it in the middle. The two buttons to the left and right of the play button basically allows you to move it one frame at a time. There are different types of videos. There are ones that might be set through QuickTime. A lot of times I'm going to try to have it linked directly to this so you can get straight to it so you don't have an issue finding the correct video. All right, so there might be like different versions of it, but they all should show essentially the same thing. Okay. Now, since you are analyzing this video, it's basically like a lab. We might have slightly different answers. We should hopefully come out to similar answers, but we might be slightly different just because of our point of view of when objects may be at particular points. Okay. So what if I want to say I want to solve for the velocity of the second skater, the velocity of the second skater. So what I would do is I'd let it run. There's the first skater that goes by. Okay. And here comes the second skater. And if I'm solving for velocity, I'm looking, actually I'll go with the person in the black coat. The second skater falls down, so I'm going to skip them. All right. What is the second skater's average velocity? Average velocity. Not instantaneous because they might be going faster or slower at any time. All right. So what I'm trying to solve for, I'll write on this, is velocity equals distance over time, displacement divided by time. So I need displacement and I need time. Well, displacement is the distance between the 2 points. So let me try to figure out, he's going to travel 5 meters from this point right here to the other side. That's 5 meters. That's what it says. The plus or minus 0.1, we will always ignore that. All right, that is to help us do basically some extra error analysis because, again, it might not be a perfect measurement. It's probably not 5.0000. I mean, we never have that. But in our course, we don't have to worry about adding in the error analysis at all. Okay? So I just basically know this skater's going to go 5 meters. I know that. That's the distance that's the only distance I can measure. I can't say 3, I can't say 2. I don't know those distances. So don't try to find a distance that you don't know. All right? So I need to now figure out time. Well, the time comes from the frames down at the bottom. Okay, if you see, it says that there are 240 frames per second. So 1 second equals 240 frames. All right, 240 frames. So what I need to do is I need to figure out what frame does, I'm going to look at the left skate. So I have to make sure I pay attention. I want to figure out when the left skate hits this line. I want to figure out what frame. He's not there yet. He is not there yet. All right. So what I do is basically, he's close. I could try to do the play button, but I might be sitting there going, oh, he's passed. So what do? I go back very, very slowly, and I go, okay, you know what? I think he has reached that line at 358 frames. So at 358 frames, we're going to say he's at 0 meters. 0 meters. Maybe change my color so you can see this a little better. Okay? So I need to figure out now, when is he at 5 meters? What frame? So obviously I'm going to let it run a little bit. I'm not going to go frame by frame all the way across. I'm going to let it run. So go. And again, I'm looking at the left skate, so I have to pay attention to that. Hopefully it crosses nicely. Oh, it does. Good. All right, let me get rid of this dot so I can see. All right, darn. He has passed the line. His skate, I want to get it right when he touches the line. All right. Does that mean I have to start all over? No. I just back it up a little bit. I back it up. Oh, I've gone too far. Let me move up a little bit. Move up, move up, move up. I'm going to say he's right there. He's made it now to the other side, to 5 meters, his left skate. So he's gone from 0 to 5 meters, from frame 358 to frame 544. Okay. So does that mean he's gone for 544 seconds? Of course not. All right. Did you see that I started at 0 at the 0 meter mark? No. 0 frames? No. The counter was already going. We have to use the frames as it's given to us. So now what I have to do is I need to find the difference in these frames. 544 minus 358. Okay. 544 minus 358. It took this person, no, not divided, I say divided, 544 minus 358. 186 frames. 186 frames took them to go from one side to the other. Is that 186 seconds? Again, no. There's 240 frames per second, so I have to do a very quick dimensional analysis. 186 frames. Frames is on top, so I need it on the bottom. 240 frames in 1 second. So 186 divided by 240. This kid, it's pretty quick, going 5 meters in 0.775 seconds. Now the thing is, when you do this, maybe you think he's there at 357 or 356 or 359 and vice versa at 543, 542. That's not going to make that big of a difference in the time. Okay, we should hopefully be very close. All of our times, all of our distances should be exactly the same, but our times might be slightly different. So my time is 0.775. So 5 meters in 0.775 seconds. The question was, what is his average velocity? Okay, divided by 0.775. I believe that this kid is going 6.4. How many things do I want? Really only one. Technically I only get one, but I'm going to go with 2. I'll leave it. 6.45 meters. 6.45, what am I saying? 6.45 meters per second. All right? He's going 6.45 meters per second, which makes sense because he's getting 5 meters in less than a second, so he must be going faster than 5 meters per second. All right? So that is basically showing you, especially the frames. A lot of people initially just have struggles with the frames and which frames to look at. You can see all I did was, what's the frame right here? What's the frame right here? Subtract. Okay, if I had to find a different skater going across, I'd basically just figure out what frame they met at that particular point. Okay, when you do the dog, I think you have to do the dog in my assignment. You obviously figure out when does the dog reach the first line and how long does it take him to reach the second line. Okay, so that is how you basically solve one of these DMV videos. Now I'm going to go to another one, another DMV video, just to show you that, again, there are some variations of how these are done. Okay, so for this one, again, same thing. You can watch the video. All right, you can maybe watch the video. All right, of course, the little stuff's not working. Oh, I'm hitting the wrong button. That's why it doesn't work. Duh. Let's hit the actual play button. There you go. So very quick video. Very, very quick video. Okay. Sorry, I'm going to have to do this one probably more at the computer. So, obviously start over, but you have all these extra little parameters, okay? For this one, maybe, again, you're trying to find the velocity, the average velocity of the car. The Thing is, this one has no distances marked at all, and it has no timer, okay? It says this is, I think, going 30 frames per second. Obviously, I will tell you whether I want you to mess with that at all, but the bigger thing I want to show you is you have these tools down here. You can turn on the stopwatch, okay? And you can turn on a ruler, all right? Now, if you have the ruler, obviously, guess what? You can set what distances you're interested in the car going. You basically move it. You go, okay, well, this is where it's at rest. I would set the ruler right there at 0. And then you can hit play. It should start the timer up top, and you can let it go. Okay? The thing is, it obviously goes past the ruler. So guess what? That probably means when you do maybe a velocity measurement, what's the average velocity at 25 centimeters? Well, guess what? You're going to have to let it go and try to stop it at 25 centimeters and come back. Well, the thing is, it never touches 25 centimeters, so maybe what's the speed at 23 centimeters or 24 centimeters? Yeah, 24. So it gives you the time. Now, the nice thing about this is, guess what? You don't even have to do the frame conversion. It gives you the actual time. It's 0.6667 seconds. Okay, right there. So I'm just trying to show, again, you have these tools available. You just don't overcomplicate it. All right? If you have the tools, use them as you need to use them. If you want to figure out how fast it's going at 50, let it run to 50. Okay? Obviously, again, it might not work perfectly because is it actually at 50? In this case, yes, it is. And you can see it reaches 50 centimeters. Again, be careful with units, centimeters, in 0.9667 seconds. So again, the stopwatch is a little bit nicer because now you don't have to do the conversion, and you can just do distance over time. You might just have to convert the centimeters. Okay? Obviously, you have a small ruler as well. There's some people that want to make it go all the way off to the end. Again, it's all your choice. This is for you to play around with. Don't overcomplicate. All right? So again, it doesn't matter. I don't need to do another one of these videos really, because when we get to forces, same idea. When we get to electricity, same idea. I mean, all of these work very similarly. Use what's available, pick easy points to try to analyze it, and go from there. All right, thanks.